Hello everyone. Today the experiment is on the DC generator characteristics. So the main purpose of this experiment is to get familiar with the characteristics of a DC generator. So to perform this experiment, we're going to need some components. First thing is a power supply, which is a lat volt series 8821-20, and the next thing would be a prime mover that's going to drive the shaft of the DC machine. So in this case, we're going to use a synchronous motor as our prime mover, which is a lat volt series 8241-00. And then here is our DC generator, which is a lat volt series 8211-00. And for the load, we're going to use a resistive load, which is lat volt series 8311-00. So apart from these components, we're going to need some ammeters to measure the currents, and also a voltmeter to measure the armature or the terminal voltage. And also we're going to use a tachometer to make sure the synchronous motor is rotating at the rated speeds. So before making the circuit, first thing we want to check is we need to make sure is we need to couple the synchronous motor and the DC generator together using a timing belt as shown in the images. So once we couple them, then we're gonna start making our circuit diagram. So for the connection wise, it's already shown in our lab manual how we're gonna make the connections. So we're gonna use our power supply to power the DC machine, power the synchronous motor, and the synchronous motor is going to start spinning. It's going to act as a prime mover and then spins the DC generator, and then once it starts spinning, the DC generator is going to generate the voltage, and then that voltage is fed to a resistive load, and based upon the connected load, we're going to see how the DC generator is working, or like it's behaving. So connection wise, first this is a three-phase synchronous motor. So on the power supply, we're going to use a variable three-phase supply, which is on connection points 4, 5 and 6. So these 4, 5 and 6, it's going to go to 1, 2 and 3 of the synchronous motor, which are the primary coils of the synchronous motor. And then we're going to make these primary coils connected in a Y shape. So we're going to short the 4, 5 and 6 together. So that's going to be the three-phase. And also the synchronous motor needs an excitation voltage, which is 120 volts DC in this case. So we're going to use a constant 120 volts DC, that is pin 8 and N on the power supply, and it's going to go to pin 7 and 8 on the synchronous motor. So this completes our connection from power supply to the synchronous motor. And now getting on to the connection point of the DC generator. So we're gonna operate this DC generator as a self-excited DC shunt generator. So for that purpose, we're gonna use a shunt coil and also a field rheostat that's gonna go in series with the shunt coil. And then getting into the connections, we can so the points 1 and 2 represents our armature. So from number 1, it's gonna go to number 5 of the shunt coil, and then from 6 to 7, which makes a series connection between shunt and the field rheostat, and then from pin 8 to pin 2 of the armature. So this completes our DC generator connection points. And from that, as you could see, these two white wires here, so this is where the voltage is generated, and we're going to connect a we're going to connect a resistive load to those points. So these two wires is going to go to a resistive load on the lat volt series 8311-00. So once we make this connection, now let's start the system and see how it's gonna behave. So before turning the supply on, couple of things to look at. First thing is we're gonna look at the ratings of these machines, so we don't wanna exceed the ratings. So first thing is, let's see the synchronous motor. When the synchronous motor when it is operated as a synchronous motor, it is rated to like 0.8 amperes. So when we are feeding the supply to the synchronous motor, we don't want to exceed 0.8 amperes of current. And when getting into the DC generator, we don't want to exceed more than 1 ampere on the DC generator. So again, we want to make sure we are not exceeding the ratings of these machines. So, and the other thing to make sure is, on the DC generator, the field rheostat should be somewhere in the mid position. You don't want to go all the way onto the full clockwise position or full anti-clockwise position. Just we're gonna leave it at somewhere in the midpoint. Okay. So when turning on to the power supply, make sure the knob is between 4 to 5 or 5 to 6. No display knob position, and then we're gonna start by switching the supply on. Okay, and we're going to set up the meters to measure the respective currents. So in this case, I'm setting this meter, it's going to measure the current drawn by the synchronous motor, and we don't want to exceed that. It's rated for like 0.8 amperes, so we don't want to exceed that rating. Right, and in this case, this measures load current, and it should be at 0 at this point since there is no voltage, and we're going to use a voltmeter to measure the generated DC voltage. Alright, so we had our all the meters ready, and another thing to make sure is initially there's gonna be like a starting torque for this machine, so you might see it might be exceeding the rated currents, but it's gonna be for a momentary. It's gonna like overcome that starting torque pretty quickly. So the display is at the 3-phase power, so we're gonna go all the way up to 208 volts. So before going to 208 volts, there are like a couple of steps that we're gonna do is we're gonna start increasing the current. Once the machine picks up the speed, we're gonna look at the rated current here. So once it's close to the rated current, that's when we're gonna turn the exciter switch on, and once the exciter switch on, we're gonna go all the way up to 208 volts. And once it is set to 208 volts, we're gonna use our tachometer just to make sure it is rotating at its rated RPM. In this case, it is rated for like 1800 RPM. So we're gonna make sure it is at 1800 RPM. And once this part is done, then we're gonna look at our DC machine, see what's the voltage is generating, and then we're gonna adjust the field rheostat so that we are able to see the rated 120 volts, whether it's generating the rated 120 volts. Once we set it to 120 volts, then we're gonna start connecting the loads to see how, and then we're gonna make a note of the armature voltage or the terminal voltage and the load current, and then based upon those values, we're gonna look at the characteristics of the DC generator. Alright, so I'm gonna start. So as you could see, once I went up to like 80 volts, it started spinning. And I could see about 0.6 amperes now. So I'm gonna go up. So at this moment, my voltage is around 158 volts, but my current is about 0.79 amperes. So I'm gonna turn the exciter switch on and then increase the voltage further all the way up to 208 volts. So as soon as I turn the exciter on, the current drops to like 0.3 amperes, and I'm gonna go up. Alright, right now my voltage is at 208 volts, and the current it is drawing is like 0.22 amps, which is less than 0.8 amperes, the rated current of the synchronous motor. So we are all good with this one. Now getting on to the DC generator side, right now I see it is generating about 21 volts. So what I'm gonna do is I'm gonna adjust the field rheostat and set it to 120 volts. Alright, right now I turn the field rheostat in clockwise direction, and I could see about 120.3 volts generated by the DC generator. So once my voltage is set to 120 volts, then I'm gonna start turning these load switches on and off depending upon based upon our lab manual instructions. So I'm gonna start like shifting like 1200 ohms or 600 ohms. And when I turn like the 600 ohms, I could see about 192 milliamperes drawn by the current, and we could see there is like a significant decrease in the voltage. I see around 150 volts at this point. So based upon your lab instructions, you're gonna connect different nodes, and you're gonna make a note of the voltage and the current. So once you are done making a note of all the voltage and current at different load points, we're gonna make sure we disconnect all the load, and then once we disconnected all the loads, we're gonna adjust the field rheostat all the way back to its mid position, and once it is at the mid position, we're gonna slowly start decreasing the voltage. So once we start decreasing the voltage, we're gonna make sure again the motor is not exceeding the rated current, and once it's close to the rated current, we're gonna disconnect the exciter, and then we're gonna go all the way to 0. So right now I'm around like 100 volts, and I see about 0.78 amperes drawn by the motor. So at this point I'm going to disconnect the exciter and then quickly go back to the 0 volts. So once you came back to 0, make sure you turn everything off and disconnect the circuit. So based upon the readings that you noted, you're gonna make a plot of the armature voltage versus the load current, and then based upon those graphs, you're gonna discuss about the performance of the DC machine, DC generator. All right, thank you.